Please state your name, followed by the number sign.
And recycling is, what recycling is you take some of the organic waste, mostly paper and soiled paper products, and you find some way to recycle them and make use of them again. And each of those avoids this organic waste going into the landfill and becoming anaerobic in its digestion process. Now, some of you probably have heard of the Green Communities GHG Reduction Project, and what we're sort of notionally calling at the moment PCT Waste Diversion Program. So the Green Communities GHG Reduction Program recognizes the value of organic waste composition, mostly household organic waste, and provides an opportunity to account for that moving towards carbon neutral commitment. What PCT is trying to offer in conjunction with this is an ability for waste programs that generate more tons than are needed to reach carbon neutral commitments to be sold. And so those extra tons could generate revenue that helps support those programs. And to do this, we are looking at generating basically a methodology for doing that and a way in which to make the calculations relatively painless and therefore enriching the program, any waste diversion program you might be chasing at a municipal level. So this is notionally how this program would work. There would be an input, which would be the organic types of waste. There's different types of food waste. They each then generate different types of emissions over time and avoided emissions. There would be a cut for the amount of tons you could claim based upon how much waste diversion was already underway. If you had a landfill gas capturing system in place, that would essentially say that you weren't avoiding as much methane because the landfill gas capture system was already eating a lot of the methane through its capture device, and then the remainder would be available to be generating carbon credits. So ideally, you would do a survey of your organic waste makeup, what your diversion rates are, whether or not you have a landfill gas capture landfill in place, and you could figure out approximately how many tons of carbon offsets could be generated for sale or for use for carbon neutral requirements. Now, to move on, there's landfill waste management, and this is once the waste is already in the landfill, what can be done? So there's sort of two sort of specifics, and large landfill and small landfill aren't, clear delineations between the two, but roughly at about 250,000 tons, you can do either a landfill gas capture system or a bioreactor process. And either one of those, you can take the gas from those processes and either pump them into the local natural gas pipelines, like it's being done in Salmon Arm. And Darcy Mooney, who's presenting after me, will describe that process a little bit more. Or it can be taken off the landfill to generate electricity. And Nanaimo's landfill, Cedar Road, has done this, and they take gas off and generate electricity and sell it into the grid. So you need a little bit larger landfill with more organic waste in place to generate a sufficient volume of methane to do this. Salt process, the sustainable anaerobic process, is basically a rapid decomposition by composting in situ. So you insert a bunch of pipes, basically destroying the anaerobic environment and creating basically a compost pile underground. And this causes rapid decomposition of the waste in the ground and reduces any potential methane, making the landfill inert in a very short period of time relative to its normal circumstances. The final sort of technology that doesn't necessarily not apply to large landfills, but is a little bit more well-suited for smaller landfills, is a biofilter. And what a biofilter is basically you go and find a main source of where the methane is coming out of the landfill. You place anaerobic microbes that are contained in a base material, and that essentially captures the methane as the methane is coming off the landfill and decomposes it into carbon, thereby avoiding the methane emissions from the landfill. And Dr. Aboud will talk to you more explicitly about that. So I've already sort of gone over these things. There's landfill gas capture systems. They can be either bioreactor type systems or just pure landfill gas capture systems. It's a piping network in the landfill that sucks out gas. Salts I've described in detail, and the biofilters also a little bit more well described here. So an example of a project that we've already purchased carbon offsets from is the Salmon Arm landfill in the Columbia-Shuswap Regional District. The project volume generates about 20,000 tons a year. They are using some of the offsets to reach some of their commitments in terms of environmental commitments, and we are buying the excess. So it's a perfect sort of marriage of opportunities. And in addition, FortisBC is off taking the gas as biogas and using it to heat homes in the region. So why is it important to us to do these things? Overall, it leads to very innovative technologies and ways of dealing with things like waste. And, you know, some folks feel that there's some pokiness to the carbon market. We don't feel that. The science doesn't bear that out. But even if it is, you know, dealing with our waste problem, moving towards zero waste, and dealing with the, you know, the troubles created by landfills will make a greener, better world. So this is a slide we always like to throw up just to keep people's minds in the right place, as it were. So thank you very much for your time. My name is Cameron Stonestreet. I'm an Associate of Business Development leading Waste File for Pacific Carbon Trust. Ben is an intern in our shop, and he's also helping. So please feel free to contact either one of us, and thank you again for your time.
Thanks very much, Cameron. And I would just like to take a moment here to actually ask you again to mute their lines. There has been just a bit of audio feedback. So again, that's *6, if you use *6 to mute your lines. And please at no time put your phone on hold. We have planned a bit of time in between presentations to take questions. So I would like to remind the audience that there's a Q&A button at the top of their screen. You could go in there and you can type in your question at any time, and we'll be sure to address it either between the presentations or during the discussion period at the end. But what I'd like to do right now is actually just continue. We'll turn over to Darcy now. Darcy, over to you.
All right, thanks, Darby. I trust that everyone can hear me okay.
Can hear you fine.
Great, and thanks for all the attendance, and certainly thanks to PCT for inviting us out. We're excited to speak to you all about the Salmon Arm landfill closure and gas utilization project. So I will get started. I guess just as a sort of a background, the community of Salmon Arm is about 16,000, 17,000 people, so fairly rural in nature. The landfill is a regional landfill, and it serves a population of about 30,000 people. We just concluded phase 1, which has about 300 to 350,000 tons in place. So just to jump into the first slide, this is basically an overview, but a landfill is really an aerobic digester, a composter that releases methane gas over time. The methane gas is pretty much released as soon as the landfill becomes aerobic, so fairly quickly after the waste is placed. And concentrations of methane in a landfill are about 50%, maybe a little bit higher. There are trace gases, generally hydrogen sulfide, other mercaptans, and other very small. These gases are largely measured in ppm. And then again, a review that methane is a greenhouse gas and has 21 times the global warming potential. So when you destroy methane, 1 ton of methane destroyed is the equivalent of destroying 21 tons of carbon dioxide, and that generates 21 credits. So just to jump into a little bit on the Salmon Arm landfill itself and the project, we operate landfills very sort of best management engineering practices has landfills being constructed as phased development and closed in phases as well. So this particular landfill has 4 phases, and we anticipated for many years that the landfill would be the first phase of the landfill, the airspace would be exhausted in 2010, and we were preparing to close the landfill then. By the regulation, that closure would not consist of an active gas collection system. It would consist of more of a passive system. But we wanted to look at opportunities. Our philosophy is we have a zero waste principle. We want to look at all waste as resources, and we recognize that methane gas is a resource. In 2007, we put out completed a gas utilization opportunities assessment that looked at how much gas we might have, and what would be the most viable option to utilize that gas. We partnered with the University of Calgary. We looked at flux modeling at the landfill. We drilled in perimeter wells and looked at how much gas was being generated at the site. And in recognition of the Terracin gas pipeline that runs right in front of the landfill, and keeping the landfill gas in that gas form, the preferred option was to, if we were to utilize the landfill gas, it was to convert it to pipeline quality biomethane and inject it into the grid. Shortly thereafter, we developed a closure plan and a phase 2 upgrade. So the phase 1 closure plan, we decided to move forward in a self-managed approach. So rather than tendering out a general contractor, so to speak, we looked at doing that work in-house and to try to employ as many local contractors as we can. In fact, we employed over 20 local contractors and created at least 2 ongoing employment opportunities to maintain and upkeep the gas collection system and the cap. In regards to the actual closure system itself, we decided to cap the landfill with a geomembrane linear low-density polyethylene liner to maximize the gas collection efficiency. It's about a 3-hectare closure and about 350 tons of waste in place in phase 1. Another thing, I guess, worthy of note is as we also developed the phase 2 collection, it was an opportunity, as this landfill was referred to as a natural control landfill, where any rainwater would percolate through the waste, leachate would be created, and then it would be the soil underneath the landfill that would remediate that leachate before it came in contact with the groundwater. That's a natural control landfill, and that's what Salmon Arm was. But we felt that with the closure of phase 1 and the expansion into phase 2, there was an opportunity to fully line and fully engineer the landfill to also give us an opportunity to utilize the leachate for recirculation. One of the key ingredients, if you will, for methanotrophic bacteria is water, and so we realized that we needed to irrigate the waste, so to speak, before, as it was drying out, to maximize gas production. A little bit on the costing. $3.85 million was our budget to close the landfill, and the additional $1 million was to put in the active gas collection system over a passive system. Here's an overview shot of the landfill nearing the completion of the liner installation. So you can see the liner installation happening around the landfill. You see at the top of the screen the phase 2 development. There's a sand layer going over top of the liner. Any leachate that would come in would be created, and that would be trapped in the liner and pumped over to, you can just see to the left of the screen, what was to be or what is now the leachate treatment area. And then rather than clearing more trees to the left to create some kind of a wetland treatment area, what we decided to do was maximize the space that we had, and we created a hybrid poplar plantation on top of the closed portion of the landfill. And what we did was we partnered with Metro Vancouver to supply us with biosolids to create a growing medium. So this was really a very innovative project in terms of the gas collection, in terms of the way we handled leachate. We ended up spray irrigating about 2,300 poplar on top of the closed landfill. This particular landfill.
Sorry, I'm just going to interrupt there for a moment. If the audience could please just hit *6 to ensure that they aren't interfering with the audio quality. Darcy.
Thanks, Darby. Just a bit of so you understand that for this project, this landfill, I think like most rural, small to medium landfills, they're not built. They're not as we build these landfills. We don't really have gas collection system, an active system in our mind. So the implementation of a gas system in this case was really an afterthought. We will now, as we're building into phase 2, we will be applying horizontal gas collection systems as we're building the layers of the landfill. But in this case, and as you can see in this slide, the first to the left shows the horizontal collection system, and we only had the ability to go down a short distance in from the surface on the top of the landfill. The majority of the gas is collected through vertical wells that are pushed down 20 meters into the landfill, and we have 6 of those. And then the gas is drawn through that system to what we currently have is a flare, an on-site flare at the landfill site. And then again, the Phase 2 leachate gas collection system, the landfill will now be operating as a bioreactor as we will recirculate the leachate into Phase 2. And then, like I said, we are also circulating, or at least putting leachate into Phase 1 to keep that waste moist to maximize the gas production. But as we recirculate leachate through Phase 2, it speeds up the anaerobic breakdown, increases gas flows, which, as you'll see in a minute, is very important to us before we get captured under the landfill gas regulation and no longer have the ability to achieve credits. And then again, any excess leachate is used to spray or irrigate a hybrid poplar plantation. Again, we partnered with Metro Vancouver, applied about a 1 to 1.5 meter topsoil, fabricated topsoil layer using biosolids on the closed portion of Phase 1, and our spray irrigating leachate on a plantation of about 2,500 trees. A few considerations, just so you get a feel for our economic and environmental considerations. Our landfill closure system, again, about $3 million. Our particular residual infrastructure is not paid for by a tax implication. It's all 100% user fee at the site, and through that user fee, we do set aside money for a closure. But of course, in this case, we didn't set aside any money for the landfill gas collection, active collection system that was just over $1 million. And we did recognize that system would create about a $60,000 annual operating cost, no funding mechanism. And so, and especially in the economic times we're in, this was important to our board to look at opportunities that could increase environmental efficiencies and financial efficiency. So we approached Terrace Gas, now called Fortis BC, to determine their interest in this landfill gas project. This isn't something that is common. In fact, there is no such project in BC. But to our somewhat surprise initially, and actually since then, we developed a solid agreement with Fortis, 15-year agreement. We received the BC Utilities Commission approval just under a year ago, and so the entire upgrading equipment is the cost of that will be borne by Terracin. So our $1 million, and then I think Terracin is putting in at least $2 to $2.5 million, possibly more. And in addition to that, Terracin will be compensating the CSRD through the purchase of the gas, and that is anticipated to fairly closely cover our operating costs. But it did leave this particular issue around return on capital, and so we looked to PCT just to explore carbon credits opportunities. So the one thing of note, as we were moving forward with the closure and the design and the planning, we did recognize that the Ministry of Environment was moving forward with the landfill gas regulation that came into be enacted in January 2010. And that particular regulation indicated that all landfills that accept 10,000 tons per year of solid waste or had 100,000 tons in place were regulated under that act. And landfills that are regulated are required to perform a landfill gas generation assessment. That first assessment was due in 2011 and are due every 5 years after that. And it's when that particular assessment shows that methane gas production exceeds 1,000 tons a year. So once your landfill produces 1,000 tons of methane gas per year, you are legislatively required to put in an active gas collection system within 5 years. And so when we looked at that, and we're under the threshold, but our engineers expect that we'll exceed that threshold in about 2020. What that means to us is that again, in 2011 was the first assessment. In our assessment, our 2021 assessment, that assessment will have picked up that we expect that we would have crossed the threshold. and then we'll have 5 years to really 5 years to be regulated. And once we're regulated in 2026, there would be no further opportunity to generate offsets. But what that means for us then is about 15 years of credit opportunity. And with that, we approached PCT, had many discussions and work and negotiations with PCT. We did have an agreement with PCT now, and that agreement will allow us to continue to offset until we're regulated. And so, just a couple of points. What ended up happening for us is over that 15-year period, and we did look at again, our philosophy is also around the waste hierarchy, and we recognize that diverting this organic material from our landfill is the best thing. So we looked at a moderate organic diversion scenario, and over the 15 years, when you factor in operations and capital, we will have our investment will have been returned to us. And not only will our investment be returned, but we'll have removed in excess of 110,000 tons of carbon dioxide from the environment just from a small rural landfill. And so, there are some challenges there, and we're currently waiting for the infrastructure to be put in place by Fortis. That's anticipated actually this month, and we're hoping to have gas moved into the pipeline within 6 to 8 weeks. What that'll mean actually is we'll be able to utilize this waste heat energy and rather than flaring on site to offset the home heating requirements for almost 10% of all the residents of Salmon Arm will be heating their homes through upgraded landfill gas. It's quite a complicated system. We need to remove the sulfur, we need to remove siloxanes, we need to remove the carbon dioxide, but at the end of the day, it's a partnership that is taking our philosophy of zero waste and maximizing waste as a resource to a new level in British Columbia. Some other opportunities, and Salim will be talking more about this, but we have explored just this year at some of our rural sites the idea of biofilters, and we have also been working quite extensively with the University of Calgary on biocover opportunities. And just so you have a sense, like I mentioned, the methane is generated from a landfill shortly after that material is placed in the landfill. The methanotropic bacteria will start oxidizing methane. That methane fugitively passes through landfill soil cover, and there's bacteria that live within that soil cover that do oxidize the methane. And so, if you can optimize the either through biocover development or creating a biofilter, if you can optimize that media to have this methanotropic bacteria proliferate in there, then it's a really low cost opportunity to reduce methane emissions at rural sites. We understand that there's some areas in BC, and Shalene will talk about TNRD. We've just implemented something. We know the East Kootenay Regional District and some sites in Alberta. Our particular project in this one is in 2005 we closed a very small rural landfill that had under 100,000 tons of waste in place, and in that closure we have passive methane vents coming out of the landfill. What we've done is we've cut those vents. We've reallocated that passive system into a bunker system. Here's a picture you can see on the left is the closed landfill, and you can just see on the closed landfill little white things sticking up. Those are the methane vents that were reallocated, and we built these bunkers. The middle picture, which is made from lock blocks, the University of Calgary helped us design and create a biofilter media that we placed in there, and we're just recently now measuring all the elements of the biofilter. As you can see, the University of Calgary guys doing so on the right picture, and doing flux measurements, and we're considering a whole host of other measurements, and hopefully we can get some interest from other sites, and we can build more sites and start looking at building a protocol for to actually get carbon offsets from these projects. But for a sense of the cost on this was about $20,000 in total for us to develop this system. So yeah, that's it for me, and here's my information, and I'm not sure if I'm taking questions now or at the end, but that's my presentation. So thanks very much.
Thanks very much, Darcy. And indeed, we do have a question perhaps for you here. And the question is, it's a little bit long here, so I can repeat it if need be. So to measure the volume, amount of biomethane supplied to the grid, and hence calculate your offset quantity, do you have a direct inline mass/volume flow measurement system, or is it inferred from the level of vacuum pulled on the landfill?
We have extensive measurements, including pressure, flow. In fact, these are all. Nothing is inferred and everything is measured, and this is a requirement of the protocol that we've adopted from the climate action or the registry. So if there's any interest, again, I'm available offline. If somebody wants to take a look at the protocol that we've utilized out of California, modified for a BC application. We've sort of gone through project design. We've gone through a validation process, and so we've sort of moved through a number of these processes that I'm certainly happy to share and can show the protocols and get more detail offline around the level of monitoring and the type of gauges and the type of systems we have in place.
Great, thanks. Thanks very much, Darcy. And what I'd like to do is actually move now off to Salim, our next presenter, and there will again be time for questions from the audience following the next presentation. Salim, can I move things over to you now? Please hit *6 on your line and go ahead.
Yeah, thanks, Darby, and thanks to all the BC colleagues for the opportunity to speak about some of the work we've been doing in Alberta and BC about methane oxidation. What I'd like to speak about today is I'll start with talking about methane oxidation. Why methane oxidation? Why are we interested in it? Then show you some results of experiments we've done both in Alberta and BC. And then I'd like to end up with talking both about the limitations and the opportunities of using this technology. And finally, as my co-author, Don May, sorry I missed, Don May is my co-author, and he's from TNRD. Unfortunately, he couldn't be here today with us in the webinar, but he had asked me to the TNRD future plans, so that will be my last slide to see where they're going to take this technology. So if we start to saying, what is methane oxidation? What I mean by methane oxidation is the biologically mediated. This oxidation is accomplished by misanthropic bacteria, not chemically. It's not an oxidation by heat or, it's straight biological reaction, and where methane is oxidized in the presence of oxygen into carbon dioxide, water, and actually in our case there will be some biomass too. Now this process occurs in our biofilter. So in the landfill, as the previous colleagues have spoken, you generate methane because of the anaerobic conditions. In the biofilter, we want to create an aerobic conditions where methane is oxidized that comes through the landfill into the biofilter. Now, the biofilter should optimize for structure of the material, retention time, moisture, pH, and other factors, especially oxygen. How does it look? And if we look at a schematic, what we do is we take a landfill that's already been capped, we cut through the cap in here, we put our biofilter in. First layer we put in is usually, in Alberta it's tire shreds, in BC we use gravel. And this is a way to distribute the flow that's coming through, so it's not channeled. And then it goes into the biofilter, and we instrument the biofilter to measure biological activity through sensors for temperature, and we have areas where we can actually take gas samples at different depths to see how the gas is being treated, and finally we take flux measurements in here. Another modification we have of this design is where we actually either build the biofilter on top of a well that's already existing, or we drill a well in here. And we tested this, and we found that if you drill a well, you bring in a lot more methane in. Now, where do we locate this methane? I'll be speaking a little bit later on that, but we try to locate them where the methane is already seeping through the landfill, because these are the hydrodynamics of the methane, of the landfill itself. So we take advantage of that. Now, why are we interested in methane? and I think Cameron alluded to that. It's one of the fairly important greenhouse gas. And if you look at the data that we know about from waste management emissions of greenhouse gases, we find that methane from landfills, this is this color here, almost every year it shows a lot higher than methane from other sources. Of course, there's wastewater methane too, which is another significant one. But methane from landfill is a very significant source of greenhouse gases into the environment in the waste management process. So it really means that we should be doing something about that. Secondly, why are we interested in this process in particular? This is some data from Alberta, and I wouldn't be surprised in Western Canada we have similar data. In this graph here, we're plotting the percent of either number of sites, landfill sites, or the amount of waste that's in these landfill sites. And you can see we have a large number of small to medium landfills that contain a lot less waste than the big landfills. Now, if you have a very large landfill, of course, like Darcy had done, you should collect the landfill and you should utilize it, either to go into the pipeline or for combined heat and power preferably. So that's what we recommend. But it's these small and medium landfills that are economic, where nothing is done and the methane is usually released into the atmosphere. Now, it gets even worse. If you look at this graph here, and this is a graph of the L0, which is the specific methane emission or methane production per ton of waste, and against the size of the landfill here, the amount of waste that's in the landfill. And you can see for the largest landfills, the specific production is a third from that of the smallest landfills. So when you have a small landfill, not only you can't afford to put in any landfill gas collection system, but even you're generating a lot more. So that's why really we got interested in doing something about something that's been left behind. So we started with Leduc, and this is south of Edmonton, and we set up an experiment to look at the potential mitigation of methane emissions, and we studied several parameters in here: temperature, moisture, oxygen, and eventually we gave them a full-scale design, and right now they've built fairly 3 large biofilters, each of about 45 to 65 meters each side, so it's fairly large scale. And in there, what would we measure? We had thermocouples to measure temperature. We took gas samples by depth, and we measured all those gases. We used TDR, time domain reflectometry, to measure moisture, and we did surface emissions using a static flux chamber. And we did that monthly for 15 months. What kind of results did we see? Here I want to show you the temperature. And temperature is very important. We monitor temperature continuously. Temperature is a measure of biological activity. As I mentioned before, biological activity is what causes methane oxidation. So it's, in a way, a surrogate for biological activity. Here is the temperature outside, the air temperature. It goes down as low as -30 sometimes. But the temperature in the biofilter stays fairly high. Of course, it's higher in the summer than in the winter. So we are definitely getting some biological activity happening in our biofilter. Does this translate into methane reduction? And here we're talking about the removal rates of methane over the period of the experiment. Again, in the winter, it's not as high as in the summer. Overall, over the 15 months of the project, the mean was 63% removal. The median was 80%, and in the last 6 months, this is in the summer period type in the last part of the experiment, where we're hitting as much as 94% removal. So certainly it seems to be working in Leduc. So I want to speak next is about the TNRD experiment that we ran, and we did 2 sites. I'm going to speak on one of them. This is Barriere. But firstly, as I was speaking before, where do we locate these biofilters? First thing we do, we go into the landfill, and this is a picture of the aerial photograph of the landfill. We do a methane scan. We walk around with a methane scanner, sniffer, where we look at what's the concentration of methane coming out from the surface. And we plot this overlay it over the map of the picture of the landfill, and that gives us an idea of where the hot spots are, where potentially we could build landfills. Why are these important? The landfill has its own hydrodynamic conditions, and probably the way methane does is it wants to go into the most preferable route to escape. And so we try to say, okay, we will catch you where you're trying to escape. And that's really what that's where we locate our methane oxidation beds. This is actually the surface after it was completed. This is where we put our instrumentation in. We go down all the way down to the waste surface. And this is after it's set up. This is our solar panel. This is our data collection system, and these are our instrumentation in here. So what kind of results we see? I'm going to show you. This is as I said, we have 4 locations, and this is the air temperature here. Again, it goes down as low as -25, but the temperature within our biofilter, it's still fairly high. So there is still biological activity, and of course, it's higher in the summer than in the winter. And if we look by depth, we have a similar pattern that the temperature in the air, the temperature in the topmost layer, the 20 centimeters, of course, varies more, but the temperature right by the landfill, the lowest part of the biofilter, is still fairly high. So all overall, we see, again, in TNRD, biological activity is fairly sizable, and that should contribute to some methane oxidation. And I just want to show you, before we get to the methane oxidation data, how with depth, this is a picture and a graph of our data from August, where we are plotting the concentration of the gases versus depth, and you can see methane at the surface of the landfill is coming out around 25%. By the time it's at 20 centimeters, it's already been reduced to about 4 or 5%. We don't have the same destruction here in November, although we have a lot less methane coming through, close to 10 or 12%, and we're only breaking it down to about 5 or 6%. So there's still, even in the winter, there is still methane being oxidized by bacteria. Overall, how did we do? And here I want to show you over almost a year and a half worth of work too. We, on the summer, we're getting almost complete destruction. We got a lot less, down to almost half to 60% in the winter, and again, back in the summer, we're going up over 90% destruction of the methane. We're removing the methane. So no doubt, it seems to be that this technology is working, and TNRD then decided to move forward with this, and they have several active landfills that are being closed in the next few years. So they're going to go forward, develop different beds, fairly large beds, and they will be instrumented so they can actually measure the amount of methane that's been oxidized, with the idea that this might lead to some certification and a protocol for getting carbon credits. And they actually are going to go back to about 30 of their previously closed landfills to see if there is any methane still coming through, and if there is, do they need to include methane oxidation beds or not. And we'll continue to work with TNRD to help them in that procedure. So finally, as I said before, I'd like to speak about the limitation of the methane oxidation technology. It's not used everywhere. So for example, if your landfill gas generation is high enough to sustain collection, flaring, or utilization, like in Salmon Arms, of course you should not use this technology, you should use it. Darcy is using it as for other landfills, not the one where he's collecting the landfill. Secondly, if your remaining landfill gas emissions are really low, and low because of very low methane generation potential, means the waste is getting stabilized, well, you don't have enough to be treated, and it's probably not significant. And the final limitation is, and that happens in some jurisdictions, you don't have enough compost and or biosolids that you can't actually build an active methane layer, an active methane oxidation layer. Now, in BC, from what I understand, is Vancouver is willing to send you biosolids anywhere, so you don't have that limitation. But in Alberta, the price of compost, in northern Alberta, it's really hard to get a hold of any compost or biosolids. And where should we use this technology? There's a couple of areas that are where these are quite useful. Where we have landfills, when the landfill gas utilization is not economically sound, especially when you have low LFG generation rates, that might be a potential there. And finally, the small landfills, which I spoke about before, where installing a collection system and utilization system is fairly expensive and it's not economic. That's where we can use this technology. This technology is passive, doesn't need any power, it's fairly cheap. You leave it in place and you don't have to look after it. There's very little to look after. And finally, actually, this is a colleague from the city of Vancouver had made this cake. She's a gourmet cook, and she actually was impressed by the landfills where we were putting some our methane oxidation bed. So it represented this, how we see a landfill. So this is the material, the original material we want to build it with. This is how a landfill cover, it's all green, and these are our methane oxidation beds. Finally, I'd like to thank people who have supported us in this research. First, we got funding for both Leduc and in TNRD from Federation of Canadian Municipalities, and of course, both jurisdictions, Leduc and TNRD. And finally, Metro Vancouver had contributed biosolids and some funding towards these projects. Thank you very much.
Thanks very much, Salim. And Salim, we do have a question written in here for you, and here it is. There are protocols available for LFG collection based on protocols elsewhere, California, AB. This aids the process of getting offsets defined and verified. Do any of these jurisdictions have an offset protocol for biofilters or bio-oxidation?
The short answer is no. The long answer is there is some that are working on, like Alberta, into this. So we don't have any other jurisdiction to emulate or borrow from. If we want to do anything, we have to do it ourselves. That's what Alberta is starting to do, but we really haven't gone very far because we're having a big look at the whole landfill issue, how it relates to waste. Similar to what Cameron was talking about, diversion and landfill, these are all connected issues. So we're doing that currently in Alberta.
Okay, thanks very much, Salim, and thanks for your presentation and all the presenters. And so at this time, we'd like to turn things over to a discussion period. So I'd invite our attendees to, again, at any time, they may type in a question in the Q&A portion up above, or you can actually raise your virtual hand by going to the feedback indicator, which I spoke about at the beginning of the session, which is in the top right-hand corner of your screen on the toolbar. And what you can do is just change the indicator there from proceed, which is green, to purple, I believe, which is question. Yes, it is. So you can just change that and address your question to. I will see that and we'll be able to proceed with the discussion period. So we welcome your questions. Yeah, I will just move along to. We did include a few questions here to try and elicit and encourage any questions. And again, we do encourage any questions at all. So I might just actually put out some of these questions to the audience. Are you now aware of carbon reduction opportunities in your community? Reflecting on the presentation, do any of our attendees wish to speak to this? And the next question was, does your community have a landfill methane management plan? Would any of the attendees like to speak to this? I believe that Ron McDonald, you just raised your hand. If that's the case, please just hit *6 and address your question to whoever you wish.
Hi there, it's Ron here. Sorry, I accidentally raised my hand, but I got a question anyway. This issue of working with the PCT about, PCT sells offsets at $25 and other people sell their offsets to the PCT. Is there an open marketplace where everyone can understand what people get for offsets? That made us a question for Cameron. Is it proprietary information what the PCT pays, or can communities talk to each other and find out what's being offered and things like that?
So I'm going to talk for Cameron on this one. It is proprietary, I should say. what we buy the offsets for from our proponents. We do sell them to the provincial government at $25 a ton, and that's a price that they've set for us, so that can't change. But yeah, it is proprietary for us to. We're not allowed to give away our prices for what we buy from the proponents.
And is Darcy required to keep that information confidential as well as part of your agreement for the purchase?
Yeah, he is.
Yeah.
Thanks very much, Ron, for your question. And again, we welcome any other questions from our audience.
Hi there, it's Bob Paul from BC Minister of Agriculture.
Hi, go ahead, Bob.
Question for Cameron. Can you just comment on that last question and how that stands up under FOI?
I'm not specifically sure how it stands up under FOI. I just know, I mean, our mandate, we're not legally allowed to disclose the price we buy offsets from, our proponents from. I'm not sure how that particularly pertains to FOI. Cameron, who actually just had to step out for a minute, but he might be able to address that a little more when he gets back.
Yeah, this is Darcy here. This is something that we did have some discussions with our solicitor about at the early stages, and I guess initially, I can share with you that my solicitor wasn't, thought that if we did receive an FOI request, this would become sort of, we would need to disclose it as public information. We as of yet haven't received an FOI request to know how much we're selling the credits for, but and we haven't really looked into it any further than that. It was just some discussions that we had at the outset.
Yeah, the reason why I asked that is local governments and provincial governments and federal are subject to FOI, and this is, taxpayers' dollars, right, being moved around. So that's why I asked that.
Yeah, we believe that that we would have to disclose it if it came through as an FOI request, but we also understand the commercial interest of PCT, and so if we did receive a FOI request, we would deal with it appropriately. We haven't as of yet received one.
Thanks.
Ron here. I guess my interest in the issue is more about educating the marketplace. This is a new area. Darcy, you're the first one to come through with anything like this, and there's probably a lot of landfill operators out there which would approach a discussion with the PCT with hesitancy if they didn't know, what the market value of their product is.
Yeah, it's difficult, I think, and I can't speak on behalf of BCT, but some of my colleagues and peers in other regional districts and other landfill owners are certainly contacting us on a regular basis, and they're being asked by their administration and in some cases their political body to look at what we're doing over here at the CSRD and run some economic models to look at whether or not a return, if a return on investment is can happen over what period and these sorts of things. So these are things that I think a lot of jurisdictions are grappling with, the economic considerations and viability and the whole issue of additionality and how that all factors into whether or not they are moving forward or not.
Great. Thanks very much, Darcy and Ron and Bob, for your questions. And again, we open things up here for any additional questions, comments from the audience, presenters. The last question we did put forward here was, does your community have any organic diversion projects in place? Or is there anyone in the audience that wishes to speak to this? And of course, we'll certainly open it up to any questions or comments from any of the audience or presenters at all.
Darby, I could speak about Edmonton if you'd like. I know it's not in BC and it's a fairly large city. Would that help?
Indeed, we are trying to focus in on our rural communities, but certainly that may be a good case study for.
Yeah, I think it's a city of about 750,000 people now. And what we have is currently, between composting, which we have the largest composting plant in North America still, and recycling, we have about 68 or 70% diversion from the landfill. Not just organic diversion, all diversion from the landfill. And what we're doing in the next year or so, actually, we already started building a plant to oxidize or burn using gasification the rest of that material, organic part of that material. And so we will end up anywhere from about 90 to 95% complete of organic from landfill. Imagine a city of about 750,000. Every day will only send about a large truckload worth of things into the landfill, which is, we'll be sending it to the Riley landfill, which is south of Edmonton. So it can be done. It is a bit expensive. Our taxpayers were, there was a gradual increase in fees for waste management over a period of 5 years, but there was a lot of support from both the community, the citizens, and city council for that. So the technology is here to do that. It just takes the will, and it will be more expensive than what we're doing right now.
Thanks very much, Celine.
You're welcome.
And again, things are open for any other comments, questions at all. Okay, we do. Looks like Herb, you've raised your virtual hand. Please, can you hit *6 and ask your question?
Hi, it's actually not Herb, it's Tara from the City of Terrace. I have a question about organics diversion. And when organics diversions were originally being discussed, it was my understanding that only curbside projects would be verified or allowed as a carbon offset qualifying project. Has that changed, or would any form of organics diversion, say for example community composting projects, be able to qualify as carbon offsets for smaller municipalities?
Sure. This is Cameron here from Pacific Carbon Trust. Under the Municipal Green Communities program, they only allow curbside waste to be, or sort of food waste to be accounted for as far as its carbon reduction. But in reality, we're concerned mostly with, is there organic waste going into landfill, and would it generate methane if it went into the landfill? And so we're agnostic or indifferent to what type of organic waste goes into landfill. We're just interested in incenting the actions that are additional to what you were already undertaking. So to answer your question quickly, is if it's organic waste, it's going into landfill and would result in the generation of methane, under the overarching sort of carbon market, there's a potential to account for the carbon reductions achieved by that. So you should be able to do the projects you suggested.
Hi, Tara. Was that sufficient for your question? Silence is as a yes, and I think the next person that's raised their virtual hand there is Malcolm Shields. Malcolm, go ahead.
Hi, this is Malcolm Shields, City of Vancouver. Continuing on the same line of questioning around organics and curbside collection, we're dealing with this at the moment in that the collection will contain both organic waste and yard trimmings. Now, the yard trimmings aren't additional, but the organic waste will be. Is there any structures in place on the protocols as to how to deal with the fact that those two waste streams will be combined, and the portion that's organic, the portion that's yard trimmings, and how that then affects the offset potential?
Great. Good question. What we are doing right now is developing basically, and if you've seen the online Excel spreadsheet, the equivalent of that in the carbon space called a protocol or quantification methodology for sort of discerning all those particular issues. It's still sort of being drafted in rough draft, and we intend to go out probably in late November or early December to get public comment on how that works. and the approach we're trying to take. So don't have a lot of details to share right now, but should be able to provide them in the not too near future.
Excellent. Thank you. I'll keep an eye out for those.
Great. Thanks for the questions. And again, things are open. See, Tara, Herb, Dustin, I see you still have your virtual hand up. If you don't have a question, turn that off. Great. Thanks. Just wasn't sure if you had another. And Bob Paul.
Thanks. Question for Darcy, if he's still there. Hopefully he's still there. Darcy, what I'm interested in is under your program to investigate other landfills in your region, are you also looking at the bigger picture of looking at maybe the further diversion of organics in the region and looking at anaerobic digestion in any way?
Yeah, can you hear me?
Yep.
Okay, sorry, I wasn't sure if I was muted or not. Yeah, this is a study that we're going to be undertaking, hopefully if our budgets are approved next year. And certainly I think there's going to be some excitement at least at the board table around potential for offsets to help, to help with the cost of these things. And but the study is going to be looking at also how we even operate landfills and it's going to be interesting in the sense that, around the landfill gas regulation, if there's some way to maximize, staying under that regulation and continue with credits to enable us to add more infrastructure. For instance, the Salmon Arm acts as a regional landfill. We have another landfill that we're looking at sort of the biofilter cover kind of technology as a way to deal with it. But if we could divert some waste that's going into Salmon Arm to the other landfill, we may be able to duplicate the process that we're doing in Salmon Arm at that landfill. And so that'll be a portion of the study as well as whether or not there's the ability to partner with the agricultural sector in the shoe shop as well to look at digester technologies and whether we can incorporate into the agricultural sector or something.
Yeah, because what we're looking at is partnership opportunities in agriculture, particularly for the Fraser Valley where we have a lot of dairy farms. Right. We want to see more diversion of manure into AD technology. Yeah. But we also recognize as a recipe mixture of feedstock, we do need the municipal side, the fats, oils, and greases, and the juicy green waste to go into digesters. So this is the opposite in that if local government is looking at digestion, what we want to do in agriculture is look at partnerships where we can bring manure waste into those kind of scenarios. So we manage the situation in a wholesome, bigger picture approach. Yeah, so we'd be open to having discussions, and this goes to any other local governments out there that are looking at digestion. I just want to also let folks know that through Agriculture Research and Development Corp, an organization we work with, they're doing feasibility work right now on 12 studies across the province. But because of the feed-in tariff that doesn't seem to be coming now through BC Hydro, that study is now being delayed because the economics of doing digestion have now changed because the feed-in tariff will not be there. So we have to look at different ways on the economics to make things work. So, but there is partnership to talk about with agriculture because we have, communities out there that have dairy operations that could be sending their material your way.
Thanks, Bob. I'm sure we'll be in touch.
Okay.
Thanks very much, Bob. And Ron, I think you had another question or comment for us. Bob?
Hi there, it's Ron here. This is Ron McDonald again. This is a question for, I guess, Darcy or Cameron. And Darcy, I can't remember the timeline, whether you're actually generating credits yet right now, but my question relates to the protocol document. How did you verify offsets when I don't think they've developed an official finalized BC offset protocol, or is that in the works, or are you trailblazing to make that happen?
I can speak to this under the EOR. It doesn't require the designation of a specific protocol, and so it's possible to steal credible protocols, and steal is probably the wrong word, but use credible protocols from other places, because landfill gas has been done in a series of other standards, and adapt it to the requirements of BC's emission offset regulation. And so that's what's being done in this case and in other cases that we worked with, at least as far as landfill gas capture goes.
So what jurisdiction's protocol are you working with then?
Darcy's group has worked with the CAR methodology, and the CDM one has been suggested for another landfill.
CAR is the California and
yeah, California Action Reserve one.
Yeah.
Great. Thanks very much, Ron. Bob, Paul, I see that you still have your indicator for question up. I suspect that's just a lasting raised hand. If not, you're certainly welcome. Okay, there, turned off. Thanks. And we do just have a few more minutes here if there are any additional questions. Okay, maybe I'll just put out a last call here for any additional questions, just maybe 10 seconds here. Okay, well, we'd like to thank you. Cameron, did you have any additional comments there at all, or?
I understood there was a question from Ben when I had to step out of the room, and for that I apologize. I'm not quite sure what the content of the question was. It had to do with pricing and an FOI request. My understanding under FOI is that commercially sensitive information isn't necessarily released, and we do have a commercial contract with the Shuswap Regional District, so I'm not sure that that information would be available through that source. But I'm not 100%. I don't know the FOI regulation inside and out, so I can't say that 100%.
Cameron?
Yep.
Yeah, it's Ron here. I asked that question. I was just asking if the pricing that's paid for offsets is publicly available, and so the response was that it wasn't. And then there was a discussion about whether it was FOI retrievable. But can you maybe just elaborate briefly on the rationale why that information? I mean, it would seem to me that for many municipal governments, that knowledge would be useful for their marketplace to understand what the pricing is, and I just wonder if you could explain the rationale for not being able to disclose that.
It's any sort of commercial rationale for not disclosing it. Particularly, we have a shareholder, which is the province, and we try to deliver the product we've been asked to deliver, which is carbon neutral government offsets, in the most efficient and effective manner possible. So in that, we get a lot more requests to sell us offsets than we have the ability to buy to meet carbon neutral government. And so we have a sense that there's a supply out there that exceeds the demand, and therefore the pricing falls below, falls somewhere below that. And then of course there's operational costs related to PCT and the overall transaction itself. Then there are other markets to take into consideration, and we don't want to be seen to, be not taking the province's money seriously when we go and purchase and incent projects. And so that, in conjunction with what our supply is, with the amount of funds that we have, and the demand really speak to the pricing we can offer. And so in every case, each project is different, requires different incentives to move forward. And as I think you were aware, Ron, additionality is also something. So we look at the project itself and see whether or not our funds need to be set at a certain level in order to make the project work as well. So there's a variety of factors we take into account to sort of arrive at a price. So it's very difficult for us to give a one price fits all, because one price really doesn't fit all.
All right, good points. Thanks.
Great, thanks. And perhaps I'll just give just a few more seconds here, maybe 20 seconds, just to see if there are any follow-up questions or last questions before we wrap up. Okay, well, again, I'd like to thank all of you, the participants, and as well all the presenters. Here are some resources we do have available to you. So the slides, again, are available to you through the handout section, and here we have the URL for the Pacific Carbon Trust, Columbia-Shuswap Regional District, and Alberta Innovate Technology Futures, as well as contact information for each of our presenters who have said they are happy to answer any questions following the presentation. And with that, I would like to turn it over to
Darcy here. I just wanted to mention that that's not my contact information. So if you want to get a hold of me, don't email P. Gordon.
Our apologies there. We will be putting out an email for a survey following this, so I will be sure to include your proper contact information at that point. And again, I'll be putting out a notice about the recording and its availability on our website. So I'll have a couple more opportunities, Darcy, to put your correct contact information out. Our apologies for that. And finally, I'd just like to turn things over to Amy to wrap things up.
Great. Thanks, Darby. Darcy, do you want to just say your email address out loud right now, just for if anyone's really eager to get in touch with you?
Sure, yeah, no problem. It's dmooney@csrd.bc.ca. dmooney@csrd.bc.ca.
Great. Thanks so much. All right. Well, thanks, Darby, and thanks to our presenters for giving us some really good information. This is, I think, is an excellent introduction to a really interesting area, and it sounds like this is one that we're likely going to be hearing more about in the future. Thanks to everyone for participating on the call. This was a really good discussion that we just had. So really appreciate the questions and the comments from the audience. And thank you to Darby and Paige, too, for organizing the session this afternoon and keeping us all on track and in touch. So as we've mentioned, there will be handout materials and a recording of the webinar posted on the Rural BC website in the next few days. And you'll be receiving a survey, and please do take the time to provide your feedback on this session today, and also your ideas for future webinar topics, where we'd really like to have the opportunity to provide webinars that are of interest, of particular interest to our attendees. So always looking for new ideas. So thanks, everyone, and have a lovely afternoon.
Thanks very much, everyone. Bye-bye.